Welcome to last video on properties of Laplace transform. So here we will discuss last property, which is the convolution property. Let's begin. So this is the statement of convolution theorem. So let's first define what convolution means. So suppose you have a function f of x and g of x. So this is how you define the convolution. So this star sign says you are taking convolution of f and g. So what this star sign means? It means this integral. So here you are integrating with respect to u from 0 to x. So this is what means convolution. So theorem says when you take the Laplace transform of this, right? So when you take the Laplace transform, the result is very simple. It is simply the Laplace transform of f times the Laplace transform of g. So this is what is written here. So capital F represents the Laplace transform of function f and capital G represents the Laplace transform of function g. So this was all about the statement. So let's see what type of question will be asked in exam. So you can expect this type of question: state and prove convolution theorem. So you have already seen the statement. So this is the statement. Now let's prove it. So we are going to prove this left hand side equal to right hand side. So you can see here we have taken left hand side. Now we are expanding L from 0 to infinity e to the power minus sx from the definition of Laplace transformation. Next what we do, again we expand this one, f star g. This is nothing but convolution of f with g. So it means this whole integral, right? Now you see this e to the power minus sx can be taken inside. So this is what we have done. And now to solve this, we are going to apply change in order of integration technique. So what is this change in order of integration? So here you can see it is integrated with respect to u and then finally with respect to x. What we are going to do? We are going to reverse the order of integration. So first we will integrate with respect to x, then we will integrate with respect to u. So while reversing the order of integration, the limits is going to change, and the challenge is to find what is the limit. So that we will do here. So in this convolution theorem, main difficulty is knowing the order of limit of integration. So let me explain this, how we will change the order of integration. So you can see here u is integrated from 0 to x, right? And x is going from 0 to infinity. So here I have plotted one graph, u versus x. So all in all you can see this integrand is integrated over the area ux area. Okay, so which area it is integrated over? Let's see that. So you can see u goes from 0 to x. So here is our u, right? So u goes from here to here, right? U go from 0 to x, 0 to x. So this is the u equal to x line. So u is going from 0 to x. And x going from 0 to infinity. It is going from 0 to infinity. Means this is the part, means this is the area over which this integration is carried out. So what if we change the order? Change the order means I am going to swap this du dx to dx du. Then dx du, if you do, then this will be the new limit. Then x will go from u to infinity and u will go from 0 to infinity. Now question is how? You see x, right? So we will do x integration first. So when you do x integration, you see from where you are beginning from here, no, you are not beginning from here, right? So you are beginning from this line, right? And where you are ending? Infinity. So x equal to u to infinity. Similarly, after doing this x integration, you are going to do the this u integration. So this is going to end where? At infinity, right? So this will be the new limit. So this is what we have written. On changing the order of integration, we find that x runs from u to infinity and u runs from 0 to infinity. So if you are still confused, you can find this topic in YouTube by typing how to change the order of integration. So let's continue. So finally we have replaced this with new order. Now you see, first we will integrate with respect to x, right? So this is our integrand. So for this x integral, fu is nothing but constant. For this x, u is a constant because x and u are independent variable. So fu can be taken out, right, from the first integration, but it cannot be taken out from the second integration. Why? Because this du is over second integral, right, 0 to infinity. But for first integral over x, u equal to infinity, fu can be taken out. So this is what we have done here. So we have taken out f, right, here. Now you see, we will redefine, right, x minus u as v. So x minus u equal to v. So what x becomes? X becomes v plus u, and what dx becomes? It becomes dv, right? Because x and u are independent. Now you see here f of u, right, and we have replaced this x minus u with v, dx with dv, and x, here x, right, x we have replaced with v plus u. So now integration is over v, so we have to change this limit also, no, earlier it was over x, so we have to change to v. So now see, earlier x was starting from u, so now if x start from u, v will start from what? So x, here x minus u equal to v. So x starts from u. So when you plug u here, u minus u becomes 0, means v starts from 0. So v starts from 0, right? 0 to infinity, correct? So we have simplified our integration. Now you see, again you can factor out e to the power minus s u, because it will be a constant for v integration. So we have factored that also out. So what remains inside is this one. Now you see, we can separate, right? This is one integration and this will be another integration. You can take du here, because for du everything inside this first integration is a constant. So here is what we have done. Now you see, u is nothing but a dummy variable here, so you can replace u with x. Similarly, v is also a dummy variable for this integration, so we have replaced v with x. And you can see this is nothing but a definition of Laplace transform. So we do symbolic representation for this f, similarly for g. So this is how we proved that Laplace transform of convolution of two functions f and g is nothing but a Laplace transform of first function times the Laplace transform of second function. Hope this video was useful.